So with that, let me start our main agenda item, which is basically me alpha testing our custom GPT that I put together, um, kind of as a natural evolution of me playing with the ChatGPT or demonstrating how to use the ChatGPT as a tutor that I was doing last year. I think I showed you the YouTube playlist where you can find them if you are interested. But those are from last year's model. So like ChatGPT itself is a lot better. And the reason I put together this custom GPT is really so that I can take advantage of the fact that I can put in the system prompts in there and kind of streamline some of the process of using ChatGPT as a tutor. Because otherwise, with the vanilla ChatGPT, I guess now you can use the learn and study mode, and it will be kind of conditioned in a way where it acts as a better tutor. But I think I showed the last time that one advantage that CoA Physics GPT has that OpenAI's own much better supported so this knows your exact class material. It has access to the lecture summaries through the end of Electrostatics, and I'm currently working on lecture summaries for this and my other classes. And in about 3 weeks time or so, I'm hoping to update it, and when I do that, I'm hoping to include the magnetostatics content there. So with that, I'm gonna actually turn into test to student so that I can kind of show you the same view that you will see. And yeah, we are still in week 2, which is where you still have to work through the modules in a linear order. I've excused the test to student out of some assignment so that I can go through this more easily. I excuse the test student out of here so that I can just move on, not have to do it. I've mentioned probably the test student is my worst student, never does any work that he feels he doesn't have to. It's surprising that he's doing this much of the problem set at all. So yeah, we are here. So let me just do a quick test. I think I did this last time before, and I haven't changed any of the system instructions since last week. So last week, some of what I was seeing, and making note of, so that when I do update the GPT in 3 weeks time, I'll put in system instructions to hoping to make it behave better. So I think when I put in a question like this, simple question like this, I think it might answer the whole thing for me. But I'm hoping maybe it'll still, I don't know. There's some aspect of randomness to it. Temperature, as AI people say. So it might tell me about elementary charge, and actually it might actually do something for this instead of just giving me the answer. We'll see. It's probably in reference to its knowledge base. Great starter, yeah. Physics 4B topic. Good. What have you tried so far? Oh. How many coulomb charge are removed? Put the magnitude. Oh, charge removed. So I can do this. Let me do the calculation, and I'll just very aggressively round it. So 3.88 E21 times 1.602 E19 minus is equal to that 620. Yeah, I guess that's right. So if you round it to 620, then it'll be graded as correct. If you round it to 600, it won't be graded as correct. So let me just, I'm just kind of checking the GPT's response. I got about 600, but it says it's should it be minus 600? and it'll probably say, I think I did something similar last time. It'll probably say that I need more significant figures. I don't think it system instructions says anything about the 1% tolerance. I might need to put that in so that it'll basically tell people to round the things to 3 significant figures unless there's some other reason to either keep more significant figures or round to an integer maybe, depending on the question. 2 fixes. Yeah, use that. Yeah, wow, it's using my. I swear, I didn't see chat. Rounding aggressively is. I came up with it on my own. Yeah, so it should be 622. Yeah. Oh, let me try the scientific notation. That should also work. The number type questions, they accept scientific notation as a matter of default. So, yeah. I got it. Thank you. So, so that was a test question. Well, one of the easier questions is to saying if a custom GPT will answer the whole thing for me, and it's the kind of the interaction that I was hoping for. So I think so far it's good. Let me and it'll always this is part of its custom system instructions. It'll ask like a follow-up, check your understanding type question. You're welcome to ignore it. If like this is a kind of follow-up question you want to answer, great, answer it. Make sure you understand, but like you can also ignore it. That's one of the nice thing about GPT. It'll basically follow your lead because it's your obedient AI servant. Let's see. This is probably on the easier end. Let me find one of the harder question. So let me imagine someone got A and B right, and they are struggling with the C. Because with the A and B, it's a simple one-dimensional thing. But with the C, I can imagine someone struggling with the vector aspect of it. So let me just put in some work that I can include as part of the prompt. Let's see here. So halfway between two. Let me try to minimize the pictures drawn. That way, as a kind of, I recommend that you draw pictures. I'm basically doing the opposite of what I normally recommend. So 2 charges placed along the x-axis, the first charge at the origin, halfway between. Oh, I think that's just 0, right? Because they are both the positive, same sign. That should be just 0. Direction is not in any direction, maybe. I hope, I think I programmed this in, but I hope that possibility has been already taken into account. Because I think these two don't have to be the same magnitude charge. So this is a point, so it's gonna be to the right because it's a negative charge. And the 2 forces that I'm adding will be net force is equal to the Coulomb constant times the 6 nanocoulomb times 7 microcoulomb for the closer charge divided by 0.5 meters squared, and then the second charge that's farther away at 1.5 meters away, and write down 6 and 6. Oh, I could have factored the things out and made it a little simpler. I'll do that when I'm plugging in the numbers. 1.5 meters squared. And I'm gonna plug in numbers into Wolfram Alpha just because that makes things a little bit easier in terms of dealing with the constants. I can just say Coulomb constant, and it'll know what that is. And I can put in these nanocoulombs and microcoulombs as they are. I don't have to 6 nanocoulomb times 7 microcoulomb, and because here the charges are the same, I'm factoring out basically this entire thing. times now the what's in the parentheses after factoring 1 over 0.5 meter squared. By the way, if you are using this functionality of looking at constants, then you have to make sure that every single quantity you put in has a unit. You have to either go all in or not at all. Either do everything just purely numerically or make sure everything you need has correct units. So 1.68 millinewton, and was looking for millinewton. In the direction I said to the right, towards those positive charges. So this should give me correct answers on those. Good. I accounted for the possibility that the charges might be the same. I'm pretty sure as a default they are not always supposed to be the same. Pretty sure, maybe. So I'll say, so I did the part A and B, but I'm really lost on how to do C. And let's even do this. At this coordinate, let's say I can do this. So I can try using almost the same expression, just with the distances updated. So half a meter, I can keep one of them, and the other one, maybe I got as far as this. I got as far as saying 1 meter squared plus 0.5 meter squared. That's basically the hypotenuse that you would have if you measure the distance for the charge that's diagonal. It's the kind of mistake that I can imagine someone who's not drawing pictures could make. I don't know if from the numbers alone ChatGPT will figure out the mistake that I'm simulating. I have a new question. Have to work out a net force on a negative charge, and I got parts A and B right, but when I tried the same approach on part C, I didn't get the right answer. What's the right answer? Just testing. It might skip to the right answer on part C or guide me through solving it. We'll see. Because the ChatGPT does have some what is it? It's like when you are calling off like a customer service and you don't want to go through the whole menu of things, so you keep pressing star, or representative. There are kind of maybe not safe word, but kind of things you can say to an automated system to make it do the thing you want it to do. So CoA Physics GPT, even though my goal is they should behave as a tutor, if you insist on just having the answer right away, it'll actually give it to you. And I don't think that's something I can prevent, because the way these AI systems are trained, they are really trained to do the thing that you want it to do, unless it violates some safety related policies. And so me doing it here, I'm doing it kind of subtly, and I don't want it to immediately give the right answer if it's at this level. Now if you insist on it, it'll still give you the right answer, but let's just see. Let's start on A and B. Foresee the clean A, to do components. And let's see. And let's say your eyes glaze over as you look at all these numbers, and it gave me the answer. All right. I don't know. I'll try to do something when I update this in about 3 weeks too, just so that it puts up a little bit of resistance, maybe try to coax you a little bit, it could give you the answer, but you will learn better if you kind of do this yourself. But let's see, can you see why the angle is so stiff? I'm not sure. I plugged in your answer and it says it's correct, so I'm sure you did it right. I just want to see how it responds. if it'll kind of go back and try to get me to engage a little bit better. Uh, all set. Yeah, I gotta work on something. Why the angle is so stiff? Yeah, I mean, sure. If you test search, I guess closer to 0. After maybe 1 or 2 more interactions, wait, closer to 90 degrees? Oh, I was doing it too quickly. At 1 1. Oh, sorry. I misread it as like I missed the fact that it's still directly above a charge. So at 1 1, yeah, what it's gonna say, yeah, that the kind of effect of the closer charge is probably more. So let me do this. Sorry, I have a really hard time visualizing all this. When you said components earlier, I saw it had I think I recognize that word, but I don't really know what components are. And by the way, this is one of the ways in which I think generative AI can be a really effective tutor as a sort of like a just-in-time review. Because when you come into Physics 4B, our assumption is that you know Physics 4A topic, that you perfectly understood everything that's covered in 4A. I mean, we tongue-in-cheek kind of. But so certain topics like cross products, many students in the past have come into 4B kind of having forgotten what 4A covers about cross products. So those you will see the reviews in the lectures themselves. But certain things, especially if it's the kind of topic that I thought most students understood well enough in 4A, you won't see me cover it in great detail in the lectures. And what I assume for the kind of majority of the class, one, I could be just wrong. Like could be wrong about majority of class, and maybe what's true for majority of class isn't true for you specifically individually. In that case, generative AI is a kind of tool that can help you to review that you need individually. So yeah, component, yeah, it's vector, has magnitude direction, and yeah, all that. Yeah, that. Oh yeah. So it's actually asking the right thing. Can you draw the diagram for this problems part C? I think that'll help me understand what you did better. So ChatGPT, it used to be that it couldn't draw diagrams, but it got a lot better at drawing diagrams. I just tested it out with a drawing free body diagram for Physics 4A 2 weeks ago, and it did it really well. So I think you can now ask for it to draw diagrams. Now, one bug that I see is, so this should expand out into an image. Let me give this a try. I'm just gonna reopen this same thing in a new window. Because when I saw my old chat in a separate window, sorry, it didn't work. I think there's some bug that, but you can work around that bug by saying, so I think forces on test chart is supposed to be the diagram, but I don't see it as an image. Can you give me a downloadable image? And it'll give me a link that I can click, download, and open. Yeah. So let's the diagram. Let's see that. Oh, I think that's actually a good illustration of the positions of the charges. Let's compare with this blue dot is the negative test charge. Yeah, at 1.05, I mean 0.5. Red dots are the positive charges. Orange arrow. Oh, don't see the arrows. I mean, if you can imagine, down left, going from here to that charge, green arrow is force from charge B straight down, and the net force should be somewhere here. So let me try this. I see this, I can see the charges locations, but I don't see the force arrows. Let's see what it does with that. Worst case scenario, I can kind of draw what I understood from its descriptions and kind of ask it to confirm, like, is this, am I drawing those forces right? Maybe the forces are too small. Let's see. Okay, I think if I tell it, so I see the forces, but okay, I see the force arrows now, but I think the F from B is still much too large. Can you reduce the scaling by maybe a factor of 3? I think that'll make all the forces visible. They were probably too small before. Yeah, so I mean, it's behind the legend, but you can kind of imagine it. Yeah, so ChatGPT is now good at drawing. I mean, it's decent at drawing diagrams. So if this helps you understand the explanations, then you can ask it for a diagram. This is the force from that, and yeah, and this goes with the explanation it gave earlier. This force from the charge that's directly below is so much larger. So I think that's enough time on this question. Let me just find another question to ask, and recognizing that I haven't fully explored, someone who's needing to review vectors and kind of trying to make sense of this. Like, if you find yourself in that situation, you probably need to spend much more time making sure you make sure you understand this vector algebra that's all here by components, calculating the magnitude, and then break into these components. And how did they break into components? Did they use the angle or directions? They used, maybe I should ask it about it. Yeah, let me ask it about it. Because let me actually do that, not rush through. Okay, the diagram looks good. I think I understand how the two force vectors are adding. Looking back up in the work you did earlier, I think I get the magnitude of the force from Coulomb's law, but I don't get how you got the force component. Can you explain? Especially -1, -0.5 divided by 1.118. And again, that's the kind of thing that I think generative AI is really good at. Maybe like even if you are using the homework help videos where I work out a lot of these questions, maybe I went through some of the steps too quickly. So you see me do it, and it doesn't make sense to you why I did what you saw me do. And you can ask me. I'm happy to answer. And usually physics related questions I usually answer within the day. I usually answer pretty quickly. But I will tell you, I'm not gonna be able to respond at the same speed that ChatGPT can. ChatGPT can respond immediately. Yeah, you kiss that where you get the direction, walk it through more slowly. Yeah. So if you see me do something like this and it doesn't make sense to you, I didn't explain it. I said, pause the video, work it out on your own, make sure you agree with me. And you don't. You can ask ChatGPT to what the detailed steps are. So here it's yeah, from the I think we can use the figure here. So the test charge is here, charge A is here, so it's getting a displacement vector by taking a difference from the, I guess it's doing the charge A minus the test charge. Yeah, so 0 minus 1 for the x component, 0 minus 0.5 for this. And this is the kind of the component of component of the vector that goes from the test charge all the way to the charge A. So minus 1 x component, minus 0.5 y component. Make sure that makes sense. Force points left and downward. And then, yeah, the division by the 1.118, that's the normalization step. It's dividing by the magnitude of the displacement vector, which calculates 1.118. So doing that gives you that. And that, I think it needs to work earlier. Yeah, I just did this times FA and kind of folded it into this one step. Now here it's unfolding it. You know, there's this RA, and then when you do that, multiply the magnitude. That gets you to that was earlier. So, yeah. I think this is good. No, that's good. I reference the force vector diagram you gave me earlier. I think it makes sense. Thank you. And let me go find maybe one more substantive question that I can go through and ask CoA Physics GPT. Let's see. This question, I wonder how it'll do. So this is not going to be the substantive question, but let me just ask. I'm just curious. So CoA Physics GPT, it has instructions to basically use what we call standard strategy when it comes to Physics 4A questions. Now, I think it knows we are in Physics 4B. Will it still use a standard strategy? That I don't know. Now, in the homework help video, you will see me use a standard strategy and basically review it for, especially those of you who might not have taken Physics 4A here. I'm stuck with this question. Where do I start? I just want to see if it'll mention standard strategy. If it does, I'll be very impressed. If it doesn't, then I think that means I have to modify the system instructions somewhat. Right now there's a kind of flow chart that first has it deciding is it 4A, 4B, and then if it's 4A, then it tries to look at is it a force analysis question, then standard strategy. So the flow chart is laid out right now. It might not even look at the 4A content it has access to once it determines it's a 4B question. Looks stuck. When this happened in the past, simply opening in a separate window seemed to just have it display. 4B forces question. What have you tried? So it's not gonna go standard strategy route. I don't know. I'll think about it. Um, uh, uh, I think I can follow the steps you lead later. By the way, before I ask another question I'm stuck on, I heard the professor mention say use the standard strategy for this question. What's that's probably enough of a kind of keyword usage for it to bring up the usage of standard strategy in the context of our classes here. Yeah, yeah, 4A, yeah. So that's yeah. So let me. I don't know how much. Well, I'll think over what system instructions might be. One where because the reason I did the flow chart thing was it was bringing in standard strategy for questions that had nothing to do with the forces. So I was trying to limit it, and I don't know. Again, I'm alpha testing this basically alpha product. So let's see. This feels a little bit close to the other question that we've done. I wonder. So there's a question where you have to use kinematics in addition to some of the electrostatics material. Maybe I can ask it the question. Yeah, it's this one. So let's do the electric field question that I think. Let's see. Can I do proton enters, plates carry charges. At this point in the lecture, have I tried? I don't think I've tried for you the formula for these. Review. Yeah, I'm pretty sure. So this question is slightly ahead of lectures in terms of the lectures that does this derivation for you. It's let me just show you where that is. But there's a hint, so I think I don't feel too yeah I don't feel too guilty. But in this lecture, preparing for Gauss's law is where I'll have done the derivation of electric field due to an infinite plate, which is what you need to use there. I think if you're only looking at these lectures, I don't think I did a derivation for I did a derivation for an infinite line, or even not even infinite line, just the force between a finite load and yeah. So oh wait, there's if due to an infinite line charge. So I've done that, but not an infinite plane. So maybe. So let's say you know either you didn't look at the hint or you looked at the hint and with all this text your eyes just glazed over. Let's just start with the so I can imagine someone trying to use Coulomb's law here. So if you're trying to use Coulomb's law, well, I got 12 centimeters there, I got a charge there, so you might do something like a Coulomb constant. Let's see. So the charge 0.8 microcoulomb divided by the distance squared, 12 centimeters squared. I think that'll be in units of electric fields at least. I haven't multiplied by proton charge yet. So that's in Newton per Coulomb. But you see electric field strength, so maybe you think, oh, maybe Newton per Coulomb is just a very uncommon unit. So yeah, you get that. So you enter 499 000 Newton per Coulomb. And let me just write down some work for ChatGPT to correct. So the work that ChatGPT should correct is, let me have it all aligned here. It should be So electric field is equal to KE charge divided by distance squared, maybe. Then so let me put this in and tell ChatGPT. I don't think we covered this in lecture yet, and what I tried didn't work. Oh wait, sorry. I should have done submit question, and it'll say it's wrong because again that's not the right expression to use. I'm stuck on this question, and I feel like we haven't covered this in class yet, and that's technically correct if you're just looking at the lectures and not the homework help videos or the hint. I tried something and it gave me the right units, but the system says the answer is wrong. And I'll let this be the last question. I think that's long enough of alpha testing CoA physics GPT for today. Well, after parts A and B, because originally I was gonna work through B. That's the kinematics portion. Again, part of this class's assignments where we bring in the stuff that you are supposed to know from physics 4A. Let's hope it'll basically give us the content of a hint. But the thing that you could find from looking at hints, you go to the textbook section, which will then textbook section, which does the derivation of field due to a plane, and I think surface. Well, that's not the one with the derivation done. There should be a. Do I have name of single infinite plane of charge? I don't have citation to a specific section, but so ring of charge, keep reading, field of a disk, and I think after they do that, they do a kind of taking the limit. Infinite plane. I think that's a keyword I've said, and so you can find this formula in the textbook section. But the way the course materials is organized, I did put that section more or less in the next week, because the point is to use the highlight how painful it is to work through direct integration as a motivating thing for learning how to apply Gauss's law. So here, point charge, that's the mistake. These are large plates, use infinite model. I think it's hallucinating a lecture, because that lecture doesn't exist, not even as a section. Field between oppositely charged parallel plates, one infinite sheet. So it's giving you the formula that you need. Again, you could find it from the textbook section, but it's a shortcut between the plates. And like this portion, you might not be quite familiar with it yet, using superposition principle, the field at sigma is q over a, and it's still doing this thing where it is giving me the whole answer right away. I'll think about how to make it more interactive so that it doesn't do this. And is it doing part B? And I think I pointed this out last time, especially with the multiple parts. It should not be doing this. It should be like if it absolutely had to give you answers, it should have given you answer to part A, and then ask you, okay, knowing what you know for part A, can you try part B on your own? That's what it should have done. Again, this is part of the alpha testing, and about 3 weeks time, I'll try to update the system instructions and try to get it to be more interactive. So. But all the content here is right. It just puts more burden on you to make sure that you understood it. I think that makes sense. I'm pretty sure this is not cover the lectures so far, so I'll be filing a complaint. Yeah, and after CoA Physics GPT response, well, this is not, yeah, it's hallucinating lectures again. So, yeah, ignore it when it's a hallucinating lectures. So, yeah. So I think that's enough alpha testing for today. Again, as I said, because it's let me leave the student view. Because it's 1 hour of me playing with the ChatGPT, it's a little bit too long. So especially in sessions when I don't have any substantive real questions to address, when I'm doing mostly this, I'll be doing it for 30, 40 minutes, and most maybe 45 minutes. I'll see how this ends up after I edit it down for YouTube. So